Well, I'm Ramsey, but today I'm Dr. Badra, and we're looking at a related rates problem, which is how much a unit changes over time. So this is the example we have today. A spherical snowball is melting. Its radius is decreasing at 0.2 centimeters per hour. When the radius is 15 centimeters, how fast is the volume decreasing at that time? So we have three steps that we gotta take. First, you gotta take the derivative, and then you gotta establish r and r prime, and then the third step is that you plug in and you get your answer. So for the first step, the volume equation for a sphere is 4/3 pi r cubed. But in order to get the derivative, since we're looking at a rate, you gotta take the chain rule of the r prime, and these two you don't have to worry about because they're constants. So basically for the chain rule there's two parts. There's like an outside equation and an inside equation. For the outside equation we have f is something cubed, and then f prime equals 3 of something squared, and then g equals r and g prime equals r prime. So for the chain rule, you have to take the derivative of the outside, which is 3 something squared, and then you got to plug in g, which is r, and then multiply by the derivative of the inside, which is r prime. So you get this. You get 4/3 pi r, 3 r's squared r prime. And then you got to establish r and r prime. R, since it's a constant, we're just going to use the centimeters since it doesn't change over time. So it's going to be 15 centimeters. But then r prime is a rate, so we're going to have to look at the centimeters per hour since that changes over time. So we're going to use 0.2 centimeters per hour, and it's decreasing. So we got to make sure we add that negative. And then the last step is that we plug in. We use the derivative equation for the volume, since that's going to tell us the rate, and we're going to use 4/3 pi 3 15 centimeters squared times negative 0.2 centimeters per hour. And if you multiply all that up, you're going to get negative 565.49. This is centimeters squared times centimeters, so it's going to be centimeters cubed per hour. And that's it for this problem.